Everyone, this is Akila from CSE Department B section, Sri Vishnu Engineering College for Women, Bhimavaram. This video was presented under the guidance by Dr. M. Prasad, Associate Professor, Department of CSE, Sri Vishnu Engineering College for Women, Bhimavaram. Let us see how to calculate the bitonicity of a given array. Let us go through the problem statement. To write a C program to calculate bitonicity of an array given with an array of integers, and the task is to calculate the bitonicity of a given array using a function. Here is the process to find the bitonicity of a given array. First we have to initialize a variable by 0. Then we have to increment the variable by 1 when the next element is greater than the previous value. Otherwise, decrement to 1 when the next element is lesser than the previous value. Now let us go through the code. First we have to write #include stdio.h followed by void main. Here I am declaring an array of size 20 of integer type, and also I am creating two variables. One is for prompting the user to enter size of the array, and another one is to rotate the loop. First I am prompting the user to enter the size of an array and scanning it into the variable n. On basis of the value of n, I am prompting the user to enter the array elements. I am here using a loop with I is equal to 0, I less than n, and I plus plus scanf %t ampersand of array of 1. Here I am using a user defined function called isBitonic, and I am giving the entered array and size of the arrays as the argument. Int isBitonic int. Here I am taking the array arr into another array called b, and the size of the array into another variable called n. Int a is equal to 0. Here I am using a loop for I is equal to 0, I less than n minus 1, I plus plus. If b of I plus 1 is less than b of I, then a is equal to a minus 1. That is, if the previous value is greater than the current value, then we have to decrement the value of a by 1. Otherwise, we have to increment the value by 1. Finally, printing the bitonicity of the given array. Let us run the program. Here I am entering the size of the array as 8. I am entering the elements 1, 4, 3, 5, 2, 9, 10 and 11. Here bitonicity of the given array is 3. When we go through this example, here starting element is 1 and next element is 4. 1 is less than 4, hence we have to increment the value of a by 1. The current value of a is now 1, and next to the 4 is 3, which is less than 4. Then we have to decrement the value of a by 1. Next to 3 is 5, which is greater than 3. So increment the value of a by 1. Now current value of a is 1. Next to 5 is 2, which is less than 5. Now decrement the value by 1. And followed by 9, which is greater than 2. Now we have to increment the value of a by 1. Now the current value of a is 1. Then next to the 9 is 10, which is again greater than 9. Again increment the value by 1. And next to 10 is 11, which is greater than 10. Again increment the value of a by 1. So when we observe the output, it is 3, and we got the correct output. This is the code to calculate the bitonicity of an array. Thank you.
Hi everyone, my name is Swati Tayaru. I'm CSC department SWAC in Bhimavaram. In this program, I will show you how to create a simple program that generates a random numbers within a user specified range. Let's dive right in. First, let's break down the program step by step. Step 1. Include libraries. We start by including two essential libraries, stdio.h for input and output and stdilib.h for generating random numbers. We also include time.h. Step 2. See the random number generator. Next, inside the main function, we see the random number generator using the seren function and time. These ensures the random numbers are different every time you run the program. 3. Take the user input. Now we ask the user for the range, lower and upper bounds and the number of random numbers they want to generate. Step 4. Validate the input. We include a simple check to ensure the lower bound is less than or equal to the upper bound. If the input is invalid, the program exits with an error message. Step 5. Generate a random numbers. Now comes the fun part. We use a loop to generate the random numbers using the formula. These ensures the numbers are within the range, lower, upper. Each number is printed on a new line. Above step 5, where magic happens, we loop count times to generate the required number of random numbers, printing each on a new line. Now let me share a few bonus tips. Improving randomness. While rand is sufficient for basic needs, for more randomness consider using random in C++ or libraries like OpenSSL for cryptographic applications. Common mistakes to avoid. Forgetting to seed. If you don't call seren, the number will always be the same sequence. Wrong formula. Using incorrect formulas might lead to number outside the desired range. Once you have written the code, it's time to run the program by using these steps to execute it successfully. Save the program, compile the code, run the program. Enter the lower bound. 2. Enter the upper bound. 9. Enter the number of random numbers to generate. 7. Random numbers in the. Now let's compile again. Enter the lower bound. 2. Enter the upper bound. 2. Enter the number of random numbers to generate. 4. Thanks for watching and keep supporting.